Hello, hi everybody. Today we are going to solve the view problems of binary tree. Starting off with the top view of a binary tree. Essentially, in the question, you're saying to find the top view of the binary tree. It is the nodes which are visible to us when we see the tree from the top. So if we look at from the top, 1 is the node which is visible to us, 5 is the node which is hidden from us. Why? Because it comes in a straight line after 1. So for this problem, first we will create a list of type integer and we will call it our answer list. So we will import from array list okay. Now we will import everything from the utility package, so I will just replace it with a star. Okay, so we are done with the answer list. Now we will create a queue. So this queue will help us to keep a track of the nodes which are present. We will initialize the queue with adding the new pair with a value 0, root. Now for those who are familiar with C++, will also know what is pair. In Java we do not have something which is special as pair, so we will have to create the class. So we will create a class called pair. It will initialize with two variables. First, which will be the distance, so distance, which will be int, and then a tree node, so tree node, and we will call it simply node. Now we will call the constructor and we will initialize. So we will take a distance comma tree node and we will call it node. Okay, now we will initialize it. So this dot distance is equals to distance and this dot node is equals to node. Okay, so over here the distance is 0, which represent that it is in the root node, so we will assign 1 with 0. Okay, and then if we move towards the left side, we will decrement it with 1, and if we move towards the right side, we will increment it with 1. So for better understanding, I have something like this over here. So to the left side, we will decrement the value, so it will change from 0 to -1, then -2, then -3, and to the right side we will increment the value, so it will then from 0 to 1, 1 to 2. Okay, and for every value we will check for the first node of the tree. For indeed that will be our answer. Now how to get that? We will create another map of type integer comma integer. We will call it a t map, so it will be a tree map, so we will call it t map and tree. Okay, now we will start a while loop and we will say that while there is element present inside of queue, so while the queue have some element present, we will run, and we will first say pair current is equals to queue dot poll. So the first the current pair we will take, so we will take out the current pair. Okay, now we will check, so we will check if map dot contains key of the current dot distance. So essentially what we are checking over here is that does the map already contains a key pair of the distance and value. So as I've already said that distance, we are starting from distance 0. So when the first time we will decrement the distance, we will reach 2. Okay, so -1 will be the index over here which occurs for the first time, so the map will not contain -1 in it, so we will put it inside the map. So we will put it inside the map, the current distance and then the current dot node dot data. Okay, so we will put the distance and data over here. Now when -1 will occur in case of 7, this condition will not become true because -1 is already present in the map. Okay, so 7 will be not stored even though 7 have the same index as -1. Hope this is clear. If you understand that, then it's very simple. We will traverse first the left side and then we will traverse the right side. So we will check if the current node have a left side, so left is not equal to null, then we will add it to the queue. So queue dot add, and we will add it as a new pair. So remember that current dot distance, and we will decrement it. Why? Because we are moving left side. And then we will add current dot node dot the left child of the, simple. And then we will traverse the right side, so we will traverse the right side. First we will check if the right side exists or not. So current dot node dot right, does it exist? So if not equals to null, then we will move and add it to it and add it to the queue. Okay, add as a new pair, we want to add it, so we will add it with a capital P. So current dot distance, and we will increment it with 1. Why? Because we are moving towards the right side of it again. And current dot node dot the right child of the node. Okay, now we will come out of the while loop and we will, the map is ready with the answer pair. So we will iterate it with the answer, so we will iterate over it. So for map dot entry, and with the entry is in integer comma integer format, and we will call it the entry, and we will traverse the map. So tmap dot entry set, and we will traverse the map and add it to answer. So answer dot add, what we will add, the eTheory dot get value. Over here the V should be capital, so we will make it, it's a small typo, and we will return the answer add or list or whatever you want to call, and we will compile it. So there are typos. So first it's saying that contains key, K should be capital over here, so we will make it capital. Then it is saying that map dot put variable map is not exist, we named it tmap, so we will have to put it as tmap. So small t capital M, tmap. Over here also small t capital M, tmap. And it's saying that q dot is entry cannot find symbol of is entry. Is entry, no, it's empty, so is empty, empty. We will run this up and compilation is done. Okay, all the test cases passed, so we will go ahead and submit it. So as we can see over here, our code is submitted, all test cases have passed. So moving on to the next part of this, moving on to our next question is the left view of the binary tree. Now the left view of the binary tree is very easy compared to the top or bottom view. So left view is self-explanatory. We will address each of this indexes as the depth. So we will add a text and we will add a depth. First depth is called 0, so we will add 0 to this depth. Okay, so we will call it as 1, and we will call this as 2. Now as the depth are increasing, you can see that for the first leftmost value of each depth is what we require. So if you can understand that, then we have our code is finished. Okay, we need the first leftmost value of each depth. So over here the leftmost value is 2, and over here the leftmost value is 35, and then 2 accordingly, and then again 2. So we will print here accordingly. So first we will need in list array. Okay, it's saying us to print, so we do not need list. So we need a set or some kind of variable to keep a track of the depth, right? So we will create a set, and we will call it set is equals to new hash set. Okay, and then we will call the solve function. We will pass in the root, the set, and then index, which is 0. Okay, now we will create it. So private static void solve, which will take a tree node of type root, and then a set of type integer, calling it set, and then an int index. Okay, now first we will check if the root is null. So if it is run, if the root is null, we cannot do anything, so we will return. Okay, now the second condition which we will check is if the depth is something which is new. So if not in set dot contains, so something which is it's not in this set, so the index is not present in the set, then we will add the index to the set. So set dot add, and we will add the index. Then we will do the simple print. So system dot out dot print, and root dot data, we will print it out, and then we will use a small space. Over here we can see there is a typo. Okay, system dot out dot println, and no ln, we will want to print it in the straight line, and then we will call it for the left side, root dot left, and then set, and then index plus 1, and then again we will call it for the right side. So root dot right, comma set, comma index plus 1. Okay, so it should run. We will run it, and we will see if it is running or not. Okay, it's saying that set cannot be found. Okay, we have not imported the utility package over here, so we will import it. So import java.util dot star. Okay, now once the utility package is import, we can use it, and so we'll go ahead and submit it. Okay, so we have successfully solved the problem as well. Now moving on to the next problem, in the right view of the binary tree, right? So in the similar fashion, now we are interested in the right side of it. So we will mark our indexes from the right side. So this will become index 1, this will become index 2. Now we are interested from in the right side view, so from right we are going to look at it. So let's get coding right away. Over here they wanted an array list, so we will create an array list. Okay, we will first import java.util.star, and then we will add the array list of type integer, and we will call it our answer list. Okay, now we will also need a set to keep a track of the indexes. So of type integer, we will call it set, and it will be in the new hash set. Okay, to get our work done, we'll pass the root, we'll pass the set, we will pass the answer, we will pass an index which is 0, and then we will return the answer. Okay, now let's create the solve function. So we will create a private static it is void and solve tree node, and we will call it root, and then we will also need a set of type integer, call it set, and then we need an array list. So array list of type integer, we will call it answer, and then an answer index. So index. Now the first condition is we will check if the root is null. So if the root is null, we will simply return. So the first condition is done. So if the root is not null, then we need to find out that if the index have already occurred. So set dot contains the index. If it does not contain, then we will add it the index, for it's a new index, and then we will also add it in our answer list because it is the node which we can see. Okay, now when we try to call the solve function, we will first call for the right side. Keep that in mind. So first call for the right side, then for the left side. Okay, and increment the index +1, and yeah, it's done. Now we will try to submit it. Okay, so successfully we have submitted the code. Now the next question is we are asked to find out the bottom view of a binary tree. Now the bottom view of a binary tree is same as that of the top view of the binary tree. Instead of the top view, we are now interested in the bottom view of the binary tree. So over here we can see that from the top view of the binary tree of this binary tree should look something like the top view should look something like 2, 1, 3, 6. You can see it should look something like this. So it looks something like this, right? So first it should be 2, then come 1, and then 3, and then 6. But for the bottom view of this binary tree, it will look something like 7, 5, 8, 6. Okay, so the bottom view should look something like 7, then 5, then 8, then 6. Same logic we will use. We will create an horizontal distance, but we will slightly modify it to our liking. Okay, so we will get coding right away. Over here also we will need a pair variable, so we will first declare the pair. So class, okay, now we will call the constructor, pass in the arguments. Okay, so first we will make the list, which will be our answer list. So integer, and we will call it answer equals to new of type array list. So array list. Okay, now after the list is created, we will also need a queue of type pair, same as the top view of a binary tree. So we will call it queue as well, QUE. equals to new linked list. Okay, then the map is created. So map integer comma integer, and we will call it t map, and new tree map of new tree map. Okay, now we will initialize the queue. So we will add it queue, and we will create a new pair of 0 comma root. Okay, then we will run a while loop. So as we have already seen that it is same as that of the top view of the binary tree. So the only difference is that instead of checking for the condition that it has already occurred or not, we will simply ignore that condition. Okay, so if it has already occurred or not, we will simply ignore that condition, and we will always try to put it. So what we are saying is that it is exactly same as that of the minus the condition in which we check that this index is the first time occurring index. Okay, we do not want to check that. Okay, so while q dot is empty is not true, then we will create a pair object called current equals to new, no, it's q dot poll, and then we will create a map dot put, and we will put the current dot distance comma current dot node dot data. Okay, so over here it's val, so instead of data we will write val. So keep, now we will traverse the array like normal. So for the left side and for the right side we will traverse it. So we will check if the current dot node dot left side is not equal to null, then we will move to the left, adding it to the queue, and we will decrement the distance. So current dot distance -1 comma, and same for the right side. So we will first check if the right child exists. So current dot node dot right child. If it is not null, means it exists, then we will add it to the queue. So queue dot add new pair, and current dot distance +1 comma current dot node dot right. Okay, now we will add the map dot _entry entry of type integer comma integer. We will call etr equals to tmap dot _entry entry set, and we will add it to answer dot add the entry set dot get value. Okay, the v should be capital over here, so value, and then we will return the answer. So return answer list. Over here I can see that I have written map, which should be t map. Okay, so that was the only mistake, I think so, only typo. So we'll go ahead and run it. Okay, so there are a few more mistakes I can see. It's saying that the error this expected. Okay, so for is misspelled. For map entry this. Okay, all of this was because we misspelled for. So now we are trying to compile it. It is saying compilation done and all the test cases have passed. I said very good, submitted, and it's checking for the last test case. And it's still checking. Okay, it's checking for optimal code test, and hooray, code is submitted. So hope you liked today's session, and if you want a more detailed review, this was just an live coding. This was just a live coding round of what questions can you expect. This is a simple 4 view questions of a tree. If you want a detailed explanation, or if you want videos like this more, then please let me know in the comments. This was just a simple 4 view questions of the tree, which is very commonly asked in the interview. If you need a detailed explanation of any of this 4 questions, then let us know in our social media account, or let us know in the comments. You can also follow our social media account to keep up to date. Thank you. Please subscribe.